All right, so let's look at a new question. So this time let's look at this problem, problem 7, the art of war. What was interesting about this question is that we did do this question, but we did it in an incorrect way, but it still passed because the test cases weren't the best. Anyways, let's go over the question. In fact, let me full screen this. And so here it is. You're the commander of an army of the Fire Nation, and you have many opponents to fight. All of your opponents have some power P gained by their victories. Some of your opponents have alliances with each other. That is, they assist each other. By the recent information received from your spies, all of your opponents are allied by all other opponents with power P minus 1 or power P plus 1. One opponent can have none or many allies. So again, a lot of story, but this time there is some useful information even at the start, and that's because the question itself is just so short, so there has to be information. But us just jump directly into the input. So there's a bunch of armies, okay, with different numbers, and now what the input is going to tell us is that these numbers represent the power of different opponents, right? So there's opponents of power 2, opponents of power 1, opponents of power 3, and what we've been told is that an opponent of power 1 is allies with all people which have power 1 less and 1 more than them. So that this 2 is allied with this 1, this 3, and this 3, right? Similarly, the this and so that also goes for all other 2s, right? So they all also have the same allies. What's interesting though is 2 is not an ally of 2, right? So that's important. And so 3 is an ally of 2's. So this. Okay, so this is how the alliances are working. Now the question continues to say if you defeat an opponent, you get all their power, but as you're not very strong yet, you do not want to fight all of them. You're looking to use some war tactics. Your counselor has advised you to call a truce with the allies of the opponent that you're going to wage war on by forcing them to break the alliance with the opponent as part of a peace deal. Be aware, after calling the truce with the party, you can't get their power. Also, many opponents can have the same power because they won the same number of wars. Your obvious goal is to defeat as many opponents as possible and gather as much power as you can. You also must honor the advice of your counselor. Right? So, what this second paragraph is basically saying is that if I decide that, okay, I want to fight someone of power 2, that means I have to ally the people of power 1 and power 3. That means I can't fight these people anymore. I can still fight the other 2s though, so I can, and let me use a different color to denote that if I can. I guess let me go with orange. So I can still fight these, but I can't fight the blue ones, right? What's very interesting here is that if I fight the blue ones, then I can't fight the orange ones. And if you look at this pattern, you might the thing that we ended up going for is that, okay, so if I fight 1, then I can't fight 2, but then I can fight 3, but then I can't fight 4, but then I can fight 5, then I can't fight 6, right? But and so this assumes that, okay, well, I'll just fight all the odd ones. So that's one option. Or I fight all the even ones. So that's the logic that we ended up applying and worked, but it's a bit faulty logic because there will be some cases where, for example, there's a bunch of colonies of 2, there's some colonies of 3, and some colonies of 4, and a bunch of colonies for 5. So now one option I have is that, oh, fight the 3s and the 5s. That's one option. The other option is to fight the 2s and the 4s. That's another option. But actually the best option is to fight the 2s and the 5s. And so you see how we're not fighting purely the even numbers here, nor the purely odd numbers. Sometimes it's better to fight a mix. Yes, if I want to fight a mix, I technically have to skip 2 numbers because I'm not fighting 3 and I'm not fighting 4. But at the end of it, it's worth it. And so, this question gets a bit uh, tricky, and it actually makes use of a very interesting concept called dynamic programming. And the basic idea is that what we're going to do is we're going to ask ourselves a simple question. What is the most power I can have by defeating people that have power up till I? So where power is less than equals to I. Okay. So if and we're going to store this in an array called dp, okay, where the index is this letter I. Okay. So if I talk about dp of 1, so that means what is the most amount of power I can have by fighting all opponents of power 1, of power up to 1. Well, if I'm just fighting opponents of power up to 1, I might as well fight the people that have power exactly 1. And so that's just the amount of people with power 1, so that's just 2. Okay. What about the power I can get by fighting everyone of power 2? Now here, I have an interesting option. So either I don't, so I have two options. Either I fight the people with power 1, or I don't fight those people and I just fight the 2. And so a way that you can think of this is, okay, if I fight people with power 1, then the value I'll get will most probably be dp of 1. In fact, if basically there's two ways of thinking about it. dp2, I can get dp2 by considering the case where I fight the people of power 2 and the case where I don't fight people of power 2. If I fight the people of power 2, then I know I cannot fight the people of power 1. I can fight people of power less than 1. So I can fight people of power 0. And then I can fight the number of people with power 2, so frequency of 2. Either I can do this, or I can just not fight anyone with power 2. And so that's the same as me saying, okay, fight people up till the power 1. So this just comes as dp1. So these two values are options for me. And what I'm just going to do is I'll just consider the max of this. And that's the whole logic behind it. So now if I say, okay, I want to fight people with power up to 3, my options are, okay, either I fight people, if I want to fight people with power 3, then I have to, the most I can do is I can fight people up to power 1 beforehand, and then I can fight the people of power 3. Or the other option is that I fight the people up to the power 2, but then I can't fight anyone else. Or if you want to think about it this way, you can think about it this way, or the other way is saying that I don't fight people of power 3, so that is the same as me just fighting people up to power 2, right? So this is the case where I fight people of power 3, this is the case where I don't fight people of power 3. And so that's the logic behind it. It's very interesting, very useful. um, and dynamic programming is a very useful concept. This is like very straightforward dynamic program, but it's still dynamic programming nonetheless. So we might as well write the code for it. Okay, and we're told the input comes in as t describing the number of test cases, n describing the number of territories, and p describing the power of each territory. So I'll just try to write it like this. So one thing I can do is I can take the t as an input. Okay, so I'm just doing that as int input, and I'm going to use a range loop. So t number of times I'm going to loop. The reason I'm using underscore underscore here is because I don't really need this variable. I don't really care about which iteration I'm on. Okay. Then what I can do is I have to input n. So n equals to int input. All right, so that's fine. Next, I get a bunch of numbers. So now if I want to take numbers as input, a nice way to do it is I can map. So I can take the input and I can split it. But these are, so that will just give me a string input, right? And I want them to be integers. So I can map it using int. Okay, so that does that. The only issue is right now it's a map, and I want it to be a list so that I can actually use it properly. Map objects are like stored slightly differently, so it's more efficient for Python, but forcing it to be in a list allows me to work with what I actually want to work with. The map object has some limitations. Um, okay, so there's that. One thing that we noticed here is that I was also making use of this frequency, so I might as well create like a dictionary for frequency. And so what I can do is I can go through each num for num in nums, I can say the frequency of the number equals to the previous frequency of that number. So frequency dot get num. And if that number has never occurred, then I just say the frequency of the number is 0 and I add 1 to it. So that will just update the frequency of the number which occurred. So the first time I encounter a 1, it's going to say, oh, let me get the amount of ones I've seen. I've never seen a 1, so I'll just say 0. I have seen 0 ones, and I just saw 1 right now. So in total, I have seen 1 1. The next time I see a 1, what I'll do is I'll check. So I'll try to get the value of the amount of ones I've seen. This time I actually have seen a 1, so this will return 1, and now I see another 1. So combined, this gives me 2, right? And this way I can just count the frequency of each number. So then the last thing that's left is creating a DP. And now what I shall do is I'll initialize DP to just start with 0, and I'll say it has as many entries as the max of numbers, so the largest power plus 1. Um, and that should be good. Yeah. Uh, yeah. So one could argue that, okay, do I really need to make a dictionary, sorry, a list that big? And I kind of actually do, because the power can go up to, so, okay. So firstly, how big will this list get? It can go up to 10 to the power 5, because power can go up to 10 to the power 5. Uh, but that's all right, because n can also go up to 10 to the power 5. So it's reasonable for me to use this much space for DP. All right. So last thing that's left is to just write the algorithm. And the algorithm basically will be this. So for p in range, max of nums plus 1, right? Or maybe instead of doing that, I can do for p in range len of dp. In fact, instead of p, for I in range length of dp. And what I can say is that, okay, dp of I equals to the maximum value between, okay, of, so if I want to fight the people of power I, then I must fight people with a power I minus 2 before that. Else, if I choose to not fight people of power I, then I can just straight up take the value of I minus 1. Okay. And this almost works, but there's some slight errors here. So firstly, when the first time this loop runs, it will start with 0. And then when it tries to do dpi minus 2 and dpi minus 1, it'll get a little bit confused. So what we can do is we can make it start from like 1. But even when we start from 1, I minus 2 is kind of weird. So maybe I should start with 2. But if I'm going to start with 2, then I have to provide the values of dp0 and dp1. So dp0 is just going to be 0, because there's no opponent with power less than 0. And even if there was, there's no point in fighting them. What will dp1 be? Well, dp1 is just going to be the number of people with frequency 1. Now here is the second issue with the code. What if there is no one with power 1? And what if there was no territory with power I? Well, the solution to that is I just do frequency.get I comma 0, because I just don't want this to throw an error. That's what I'm trying to avoid. And this should be enough to actually solve the problem. It's very short code. It's very pretty code. But it's very smart as well. And so now if we go ahead to test it, so I put in three. So there's three test cases. The first test case has two inputs. The input is 1 and 2. The output is not supposed to be traceback, but I got a traceback, right? And that's because I put an I here when this should have been a 1. So that's my bad. But yeah, 3, 2, 1, and 2. And this is interesting. It did not output anything because, again, I forgot to add a print statement. And the question is, okay, well, what should I output? Well, if you think about it, I should output the most power I can get by fighting everyone of power. Sorry, fighting everyone of power. Yeah, of fighting everyone of power up to the max power. So I could just do the last element of DP and that will give me the value, because this will just tell me the max power of fighting everyone with power up to the largest power. Why the largest power? Because that's how the dictionary, so the list was defined, that the final index equals to the maximum power. All right, but there's another issue which I've been making, and that comes from like reading the question poorly, is that I've just been doing frequency.get. Another thing that I have to do is actually, if there's like 5 territories with power 2, my answer isn't 5. My answer is 5 times 2, because I have to, when I fight the territory, I get the power of the territory, not just, so it's not just dependent on the number of territories I fight. But so this small addition will do it, where I just say, okay, find the number of territories I'm defeating and just multiply with the power of those territories. And so now, finally, if I try to run this, I type in 3, I type in 2, I type in 1, 2, I get 2. Okay, if I type in 3, I type in 1, 2, 3, I get 4. If I type in 9, I type 1, 2, 1, 3, 2, 2, 2, 2, 3, and I get 10. And so all of my outputs match the desired outputs, and we're good to go. Thank you.